This is Dr. D. Gokila, Assistant Professor, Department of Computer Science PG, Christ Jayanti University. Today I am going to say about semaphores in your operating systems. So, I am going to see the content in such a way that what is a semaphore, the methods used for semaphore, the types of semaphore and semaphore implementation. Here I am going to deal about there are many types of problems. In this video, let us see about dining philosopher's problem. So this is the overall agenda of semaphores. So what is a semaphore? A semaphore is a variable or abstract data type that is used to control a common resources by a multiple resource in a concurrent system, such as it is used for multiple operating system. A semaphore is also a variable and an abstract data type too that controls a common resource. A semaphore is an object that consists of a counter, a waiting list of a process and the two methods. One method is called as a signal and next one is called as a wait. So synchronization is the main concept in the using of semaphore, and the synchronization tool does not require any busy scheduling spin lock. So this is the overall introduction of a semaphore. So we have to keep in mind such a way that semaphore is a variable or an abstract data type. So what are all the facts important regarding to the semaphore is it is a mechanism that is used to provide a synchronization, and it is also a low level of synchronization mechanism. It was introduced by Edgar Dijkstra in 1965 to provide a competition synchronization and also cooperative synchronization. It has a data structure that contains so it is devised in 1965 by Edgar Dijkstra to provide a competition synchronization and also cooperation synchronization. It is a data structure that contains an integer and a queue that stores the data descriptors. Semaphore has two operations. They will be passing and waiting and releasing. Originally, when we name semaphore, we have two values. One is signal and another one is wait task, which is named as P and V by Dijkstra. So P stands for signal, that is to pass the signal, and V stands for wait, that is virgin to release and wait that particular semaphore. So this is a method used in semaphore. The semaphore method consists of wait and a signal. So an example is given such a way that the semaphore is dedicated with the help of a variable called as S. So S dot count minus minus and it should be less than 0. So whenever we are continuingly initializing a semaphore, a value will be decreased. After decreasing the counter to be 1, then it will become negative. So till it becomes negative, the value will be decreased one by one in a semaphore. And after all the values have been decreased, it has to be made in such a way that it is added to the waiting list and it will block by itself. The resources are occupied in such a way that to process the semaphore to occur. So as we said that we have seen what is semaphore, the futures of semaphore. Now we are going to see about the dining philosopher's problem. The process are competing for exclusive access to the limited number of resources. The philosophers will eat and think according to the dining philosopher's problem. So the dining philosopher problem is used in such a way that we can take a real-time example that we will be adding eating two chopsticks, and one chopstick is used for picking at a time and one is to prevent the deadlock. So we have to make the initialized value to 1 in such a way that the chopsticks are made to the semaphore. So this is an example of a dining philosopher problem. So whenever we go for dining philosopher's problem, we should make in such a way that the left fork will be simultaneously having a pickup value with the right fork that is not at all available, and repeat the process. This process is called as starvation, that is used to release the deadlock condition, and each could wait a random amount of time before picking up at a right fork. And it is a situation that is used for a good solutions of all applications. Primarily, when we use a dining philosopher problem, we must use only binary semaphore that would enable one philosopher to eat at least one time. So if we have two philosophers where one philosopher eat only one at a time, that can be used to avoid the starvation. That starvation will result in the dining philosopher problem. because whenever we go for dining philosopher problem, we have to make in such a way that we will put the left fork simultaneously in order to make the starvation to occur. Starvation is a condition that would be a random amount of time will we pick up a right fork at the right time. So thank you for hearing all those things. Thank you, students.